Good morning. So today we're going to talk about parabola word problems. Now the most important thing to know here is that most parabola word problems, not to say all of them, follow the same streamlined process in Algebra 1. So they will always ask for, not always, but they will 90% ask for the same things. And if they're asking for the same things, then we can learn a way to look for those things and refer back to it and get the answer regardless of what equation the problem is giving me. For example, I have put here your quintessential parabolic problem. So this is the problem that everything will be based off of. And you'll see the more that you do these problems, they always tend to look somewhat the same. And again, always is not a good word, but for Algebra 1, 90% of the time these problems look the same. So now this problem here says a ball is thrown in the air. The height h of the ball in meters after t seconds is modeled by the following quadratic equation. Now I don't have a quadratic equation. I didn't put an equation per se. And I also haven't asked you any questions. What I want to do first is show you graphically the things that can happen and the things that we can look for, so that then we can refer to what I think are the 5 most repeated questions when it comes to this problem. So the ones that they will ask you the most. Now, so imagine this scenario. Imagine you throwing a ball. Now we talked about this in class. If I'm throwing a ball, if a rocket is launching, if my income curve is positive, if my company is making some kind of profit, all of those images will look the same. All of those graphs will have the same outline, right? And we create some kind of curve going up, reaches to a point, and then it starts to decrease, right? So I have a negative parabola, if you would. It starts at the bottom, it rises up, I get to some maximum point, which some of you know as a turning point, and it starts coming back down, and we're back at 0. Right, so I have some curve. Now, I don't know where this curve ends, I don't know where it starts, I don't know what the highest peak is, I don't know any of that. And those are the things that they're mostly going to be asking for. So let's just do a general outline of that would look like, and when they would ask me something, what part of the problem gives me the answer. So let's say I draw the path of a ball thrown in the air, and I'm gonna start to the left of the y-axis, and you'll see why. So I have my y-axis here, and I have my x-axis right down here. So let's say I have the path of a ball. So I'm going to start somewhere here, and I'm going to throw the ball, and it's going to, let's make sure that that lands inside of it. So I have something that looks like that. Not a perfect graph, but that will do. Now, if I'm looking at my sketch right now, I have 2 directions. So I'm going upwards, and I'm going towards the right. In terms of what is actually happening, if I am going higher and higher and higher, well, that dimension will be my height. That my y-axis is how high I'm going, right? So my y-axis is going to be my height in this case. My x-axis at the bottom is not where I'm going to land. So what the bottom is telling me is how long does it take for this particular ball to land. So if I throw the ball up in the air and I start at 0 seconds, so you'll see again why I'm to the left of the y-intercept. If I start at 0, how much time is it elapsing until the ball falls back down? So here my x-axis is going to be my time. Now my time could be in seconds, minutes, hours, days, it doesn't matter. My height could be meters, miles, centimeters, inches. So it could be a plethora of things. So again, most of the time, this is what it would look like. I will have a downwards parabola, my y-axis will be height, my x-axis will be time. So if I throw a ball up in the air, there's a few questions that I naturally want to ask. So my first question, if I throw something up, is, well, how high did it go? And if I look at the parabola, there's a point in the parabola that tells me how high it went. And that point is called the maximum point, right? So I know that my maximum is right there, and I also know that as the vertex. Now, each vertex has 2 points. It has some x value, and it has some y value. Which one of those tells me the height? Because I'm only interested right now in how high it went. Well, for me to know how high it went, I'm looking at my y-axis right here. So I'm only looking at the y of the vertex. So that point there is going to tell me my maximum. So this will always answer the question, well, how high did it go? Maybe what is the maximum, or what is the peak? What is the top of my income, right? So something similar to that, something that it's talking about the height of my parabola. And again, most of the time it will just be how high is the ball. And again, I'm just looking at my y in the vertex. Well, the next thing that I want to ask, or the second thing I would ask is, why did I start here if I know that this is negative? So let's say this was some negative value. I can't really have negative time, so I need to ignore that part of the graph. So what is this point here telling me? My y-intercept. Well, if I think about it, this is at 0 seconds. So my y-intercept is at 0 seconds. That is when I must have started to throw. But I already have some kind of height. Well, what that tells me is that I didn't launch the ball from the ground. And if you think about it, it makes sense, right? If I'm 5'10", so if I were to throw a ball, if it was a football and I was throwing from here, I'm a little over my head. So maybe I'm throwing at, I don't know, 6 feet. If I have full extension, I'm throwing at 7 feet. So that's what's happening here. So my y-axis, my y-intercept, tells me how high was the ball when I started. So where did I throw the ball from? So my y-intercept is going to be telling me, where did I throw from? Or where did I start? And that makes sense, right? If I'm throwing something, I'm probably not going to be reaching down to the floor and scooping it up. I'm going to go behind my back and throw it. In the case of a rocket, it's a little different. So a rocket would launch from the ground. So maybe I'll have something that starts at 0 and then goes. But that's not the case here. So be open to the idea that I could start from 0 or at some height. Whatever my y value is going to tell me, or whatever my y-intercept is going to tell me at what height did I start. Well, if I know that if I know that my x-axis is time, and I know that I started at 0, then this point right here is going to tell me when I ended, right? So how long until the ball fell? So when did the ball reach the ground? So my second 0, my farthest 0 here, will always answer the question, when will it reach the ground? When will it, let's say, hit the ground? Right, so now I have the answers for the question, how high, where did I start, and when will it hit the ground? Well, now I addressed what the y in the vertex did. I haven't talked about the x. So the x of the vertex is my axis of symmetry, and we've seen this before. There's an invisible line here that splits my parabola in two equal sides. My x in the vertex tells me when I reached my peak, so when I was at my highest. So I could know that maybe my ball was at a height of 10 meters. But what I'm interested in is to know how long did it take for the ball to get there, to reach that highest point. So my axis of symmetry will always answer the question, when will I reach my peak? When will I reach the max? Right? So again, when will I reach the highest possible value? When will when will I make the most money? When will my savings be at the top? When will my ball reach its highest point? And those are the four main questions that you're going to be asked. So where did I start? How high did I go? When will it hit the ground? And when will it hit the maximum point? There's one extra question that comes up, and not as often as this last one, but is the intervals at which I'm increasing and the intervals at which I'm decreasing. So if I look at the path of a ball, my ball has to go up and then down. So maybe what I'm interested in knowing is, when will this ball go up, right? So it's going up from 0 to whatever value that is, whatever x value that is. And when will it go down? So maybe I want to know how long it took for the ball to fall down. So now I'm looking at this point from here all the way to the ground. So let's say that this is 0, let's say this is 5, and let's say this is 8. So, or backwards, this is 11. So in that case, I know that it took 5 seconds for the ball to reach its highest point, and it took 6 for it to come back down, right? Because I went from 0 to 5 to get to the top, and from 5 to 11 to get back down to the ground. And those are my intervals. So it took me 5 seconds to go up, and it took me 6 seconds to come down. And those are the 5 questions that you will be asked in a problem like this. So what I'm going to do next is we're actually going to put some values to the equation and actually try to solve all 5 of them. So go ahead, take a minute, copy this down, make sure that you have it, and then we're going to refer back to it. Okay, so let's add some equation to this problem, and let's solve for the 5 things that I told you I think are the most common in this kinds of problem. So let's say, and again I have the same prompt. So a ball is thrown in the air. The height h of the ball in meters after t seconds is modeled by the following equation. So I want some function in terms of time. So I want height in terms of time. So this will be then f of, so let's say the equation will be f of t is equal to negative t squared plus 8t plus 9. Okay, and again, please have in mind that my a in this case is negative, and it will most of the time be like that, because in order for me to have a downwards parabola, my a has to be negative. So off of this quadratic equation, we're going to get asked these 5 questions. So we're going to try to answer all of them. Now, I'm not going to answer all of them in the same graph. I'm just going to sketch the graph once, and then we'll talk about what each one of them is asking me. So again, this graph would look something like this. So I'm throwing a ball up in the air and it's falling down. So let's say that, and again, this is my y-axis, this is my x-axis, this is time, and this is height. In this case, I know that my height is in meters, and I know that my time is in seconds. So let's go for question number 1. So what if they were asking me, when will I reach my peak? So when will the ball reach the maximum point? So when will the ball reach the maximum point? So if I look at this graph right here, the maximum point will be somewhere here, and that I know it's my vertex. So it's asking me when. So I want in terms of time. So I'm looking at my x-axis, and I want to know when will this maximum point happen. Well, that is my axis of symmetry. So in order to answer when will the ball, I need to use the axis of symmetry equation. So whenever they're asking me when will the ball reach the maximum point, I need to use the axis of symmetry. Right? And the axis of symmetry equation is x is equal to negative b over 2a. And that will give me the x value. So in this case, our equation was f of t is equal to negative t squared plus 8t plus 9. And again, this comes from, this is the same thing as saying f of x is equal to negative, or rather, a x squared plus bx plus c. So I want my b values, I want the opposite of b, divided by 2a. So let's list that down here so we know. So my equation was negative t, so let's make that f of t is equal to negative t squared plus 8t plus 9. And this is my a value, and this is my b value, and this is my c value. So I want the opposite of b, so x is going to be the opposite of b, which will be negative 8, divided by twice the value of a, so 2 times, and the value of a here is negative 1. So this will be 8, or negative 8, divided by negative 2 is equal to positive 4, right? So when will the ball reach the maximum point? Well, the ball will reach the maximum point at 4 seconds. And that is my answer, right? And there's nothing else to do. And the trick here is knowing what they're asking me. So I looked at my graph, and they're asking me when will the ball reach the maximum point. So I drew my vertex, and I said, well, what I need is my axis of symmetry. And I was done with it. So if the first question is when will the ball reach the maximum point, naturally my second question will be, well, what is my maximum point, right? So what is the highest point that the ball could reach? So let's say that number 2 was, what is the highest point? Right, so what is the maximum point? What is the farthest this ball can go up in the air? So I look at my graph again, and I'm reminded that my vertex is some x comma y, and I already got the value for my x. I know that my x is 4. This down here is 4. I was able to find out that my maximum happens at 4 seconds. Well, now I want to know the y value of it. I want to know what the maximum point is. And in order for me to find the maximum point, I need to grab those 4 seconds and plug them in to the original equation. So the original equation here was f of t is equal to negative t squared plus 8x plus 9. So all I have to do is go ahead and plug those 4 seconds in and see what the height is. So this will just be plugging in. So I'll have f of 4, right? So f of 4 seconds is equal to negative 4 to negative 4 squared. And this is exclusive. This is not telling me that the 4 is negative. This is telling me that whatever value comes from here is going to be negative. So this is 4 squared, and that's going to be negative, plus 8 times 4 plus 9. Well, if I follow order of operations, this is 4 squared, which is 16. So this will be negative 16. And please make sure that you see that the negative stays outside of it, and then I bring down the 16. So it'll be negative 16 plus 8 times 4 is 32 plus 9. And this I can just put into the calculator or do it in my head. This is negative 16 plus 32 plus 9. And that will tell me that f of 4 is equal to positive 25. So the maximum point will be, or the highest point this ball will reach, is 25 meters. So 25 meters, and that will be my maximum, right? So in order for me to find the highest point, all I did was I went to my graph, I drew my vertex, and I found that my maximum was 25 meters. Good. So 2 more things that I want to ask right off the bat is, well, when or what height did I start, and when did I land? So let's do where did I start. So let's do number 3. At what height was the ball thrown? Again, so let's rewrite the function that we had. So our quadratic equation was f of t is equal to negative t squared plus 8t plus 9. Now we talked before about this point right here. Where did I start? And that is simply my y-intercept. So if I scroll down back to my question, I look at my problem, and I should know by now that my y-intercept is the c value. So this right here is going to be my starting point. This will be my y-intercept. So my y-intercept is equal to 9. Therefore, I threw the ball at 9 meters, right? So I started throwing the ball at 9 meters. And this could have been me on a second floor building. This would have been me on top of a ladder. This would have been me at the top of the bleachers. This could be a plethora of scenarios that are not given to me. All this tells me is that I started throwing the ball at the height of 9 meters. Number 4. Well, what if instead of knowing at what height the ball was thrown, I wanted to know when is that ball going to land? So I just threw an object up in the air, or a rocket launched, and I want to know, well, when is it coming back down? So when will the ball land? And again, if I look at my little sketch and I'm looking at the path of my ball, I follow my ball and I want to know when will it land. So if I'm talking about landing, I'm looking for my 0, and you'll see now that I'll get a positive 0 and a negative 0, and because I can't have negative time, I'll just concentrate on this answer right here. So when will the ball land? I have f of t equals to negative t squared plus 8t plus 9. And there's a few ways to do this. I could factor this, I could put this inside the quadratic formula. This one is a pretty simple one, so I'm just going to factor it. If I'm not comfortable factoring, then by all means you could just use the quadratic formula. So if I want to factor this, this will be f of t is equal to, I have a greatest common factor, so I want to take out that negative, and that will change all the signs inside. This will be t squared minus 8t minus 9. And now I'm left with a leading coefficient of positive 1, and I need two numbers that multiply to negative 9 but add up to negative 8. So this will be f of t is equal to negative outside, and this will be t minus 9 times t plus 1, right? Because negative 9 times 1 is negative 9, and negative 9 plus 1 is negative 8. Now I want my zeros, so I need the opposite number, so I need this to be equal to 0. So 0 is equal to negative t minus 9 times t plus 1. And here the only things that come out is the opposite of this value, so this will be t is equal to positive 9 and t is equal to negative 1. Now this is in terms of seconds, so this says t equals to 9 seconds, this says t equals to negative 1. I cannot have negative 1 seconds, therefore my ball would land at 9 seconds. Right, so t is equal to 9 seconds. Good. So now I found out that it lands at 9. It started at 9 meters. It reached a height of 25. It reaches the height at 4 seconds. And the only things that I'm left to find is the intervals. So when is this ball rising? When is it falling? So we'll do number 5. When is the ball rising? And we'll call it 6 for the sake of separation. When is the ball falling? So what times, right? So if I look at the graph here, I started at 0. I threw the ball and it rose from 0 all the way to 4. And I'm looking here at this interval at the x-axis. So between 0 and 4, it rose. So I'm going to write between 0 and 4, it increased. And then between 4 and 9, it fell to the floor. So it fell back down. So between 4 and 9, it went back down to the floor. And 4 being my turning point, right? So I'll write this as, when was the ball rising? Well, the ball was rising between, well, what is that? The ball was rising between 0 and 4. And the ball was falling between 4 and 9, right? So if the question was, how long did the ball spend rising, you would say 4 seconds. And if the question was, how long did the ball spend falling, then the answer would be 5 seconds, right? And those are the what I'd like to call the 5, 6, if you would, most common questions when it comes to word problems. So if you go through these, if you copy this down and you pay attention to the examples, you'll be able to solve all of the quadratic problems that you're assigned, because they all follow the same properties, the same layout. Okay, so I want you to go ahead and take a look at the ones that I've assigned online, and go ahead, and if you have any questions, just send me a message. Okay, so have a good rest of the day.